Clearly there is from a network perspective, there's clearly a need for continuing to improve latency, and that's always something that's been talked about quite a bit. I think our view is it's not just about speed, and it is very much about the quality and consistency of data that flows through those networks. I think the types of applications that run on those networks are very super sensitive to actually blips. And I think operators need to get more and more increasingly aware of that, because when you're in a market and you're trading, you don't want these blips to take you out of the market, and they can do because these applications are super sensitive. So I think the first thing I would say is really about consistency and quality. I think the second thing is getting to understand what the financial institutions are really using the network for. Was a revelation in some ways, because I think then you really can understand how to put it to better use. So if someone's really using it to, in essence, reach multiple locations, it's a very different usage scenario as someone who wants to get the most out of it in a particular location. And in our presentation, I mentioned that London, for example, is starting to collect around a couple of different hubs. They're very small distances, but actually very, very important that that hub works extremely well. And then you've got the long distance issue, which is a completely different issue.
From a technology point of view, the IP protocols, UDP, TCP, are normal transport mechanisms, but as well with remote direct memory access, converged Ethernet, some higher end protocols that are really supportive of the ultra-low latency behavior that's needed by our customers, how to take that, which is now generally a local data infrastructure system, and try and get those kinds of techniques distributed across the WAN over Ethernet is a challenge, and is new territory that we hope over the next 12 to 18 months we see new and emerging technologies that make ultra-fast technologies really supported in a WAN infrastructure.
So what we provide specifically, in fact, and there are a number of players, I alluded to the fact that this is a very crowded industry at one level. Everyone's doing very niche things, and the trick is how do you bring all these bits together and make them work. So what we really bring to the table is we have a very broad coverage of markets where people do trade. So we actually connect with our own network, which is built on 5,500 kilometers of dark fiber, all the latest switching gear, all of that good stuff. We actually connect a number of venues, and we provide market data from these venues to our clients. So they can actually get the data off this network that we've built in the co-location of the various markets, and they can route their orders as well back. And I think that integration is really quite key. So one or the other isn't good enough. You kind of need to put them together. So that's one of the ways that we address the needs.
And some complexities around tiering of networks. So within stock exchanges or ATS market venues, there's servers and connectivity. Then customers, brokers, etc., have their sets of tiered networks, things that are used for trading and infrastructure that's used for clearing. It's a very complex set of layers of networks, and the industry is driving to flatten those networks. So as we push to flatten them for the high-frequency algorithmic trading space, we also see a drive to flatten them for the back-end internal infrastructures, making them much more cost-effective, and look to that over the next generation of technologies and deployments.